Our first speaker is Dr. Breno Fragomeni. He's a PhD in animal breeding and professor at the University of Connecticut, USA. Last year, he was covering the genome-by-environment interaction at our conference, speaking of how genomic evaluations might differ from country to country and why every country tends to make their own database and their own evaluations. If you haven't seen this, refer to us. We can send you his last year's speech or just watch it on our YouTube channel. Today, Breno will delve into the complexities of international bulls evaluations for dairy cattle, explaining how to work with bulls evaluations from foreign countries, from different countries. Breno, hi. Can you see Breno in translation? Yeah.
Perfect. So, well, first of all, thank you for the invitation. It's a pleasure to come back and talk a little bit about my research. So, as Selena said, I'm an assistant professor in animal genomics here at the University of Connecticut. And I work with dairy cattle genomic evaluation here in my laboratory. And one of our focuses is genotype by environmental interactions, but also working with how we can use genomic evaluations from different databases to improve, especially when you're talking about countries that are that have less data than others. And I'm going to go more into details. But it's nice when I received that invitation to talk about international genomic evaluations, because I have a Russian tree here in my backyard. And when I identified a tree and I went online to look at the images, it doesn't look as good as the original images from that Guelder rose or Kalina tree. I think that's how it's pronounced. And probably because this tree was actually brought by the previous owner of my house from Russia, actually, and is just not well adapted to this environment. And very similar thing happens with animals when we try to use animals from different regions into ours. Of course, in dairy cattle, we usually do not export live animals, but it's very easy to import semen. And relying on evaluations from different countries can be quite problematic. Can you go for the next slide, please? So, in summary, my presentation is going to, sorry, I'm just trying to make it. Okay, perfect. So in summary, my presentation is going to talk a little bit about international genetic evaluations and genomic evaluations and how that can be considered basically in three different ways. What are the problems and what are the solutions? What people are doing to improve that? And I'm going to briefly talk about the new research and the new technology that is being used and is being developed right now to bridge those gaps. Next slide, please. So when we talk about international genomic evaluations, the very first thing that we think is the multi-trait across-country evaluation by interbull, which is also called MACE. Basically what MACE does, it combines data from 30 different countries that are members of interbull. And even if animals are not evaluated in every single country, after they go into that MACE evaluation, it calculates PTAs for every single animal in every single country. And MACE takes into account that not every country is the same. So it takes into consideration that the best bull for a given country is not necessarily the best one for another one, which makes it one of the ideal tools for that. However, there are limitations. If you think about the number of data necessary to run an analysis across 30 countries, there will be a limitation, for example, in number of traits. So traits that are necessary to be evaluated in a single country may not be interesting to another one. So bulls are not going to be evaluated by maize for everything that every country judge is important. Therefore, domestic evaluations are still important, even if countries are a member of maize. And of course, countries that are not members of Interbull, they will still need to run their national evaluations. Next slide, please. So before we talk a little bit more about international evaluations and some details, there is one thing that we gotta focus on PTAs or breeding values. I use the term PTA. That's the most common one used in dairy cattle evaluations. But PTAs are extremely specific to populations. And even within the same population, they're specific for the year of that evaluation. So if I take the herd book from last year and this year, I cannot compare them. I cannot compare animals from year 23 with 22 because sometimes the base of the population changes. What the PTA means is that how much that animal genetics deviates from the base of the population. Now that can be the average of that population, so we can set the average of the population to be 0, and then the PTA is going to be how much more an animal will produce. But sometimes we put fixed bases. For example, the base is going to be a specific individual or a goal, and sometimes you use the same data, and 2 different companies are going to release herd books, and they're going to have different PTAs for the same bull using the same data. So comparing PTAs from different herd books is a really bad idea. So in that example here, we have an animal with 1,000 PTA for milk, an animal with 1,500 PTA for milk. Basically, the best definition we can do here, if they're in the same, I can assume that the 1,500 animal is 500 pounds higher than the 1,000 pounds animal. But other than that, I cannot make that comparison with a different herd book or a different breed or a different year and so forth. Next slide, please. So one of the reasons why we cannot compare different evaluations or use evaluations for different country into ours is genotype by environmental interactions. So just like the tree in my backyard, sometimes we select a bull based on what is expected in a specific country, and that bull just cannot express that genetics into our country because feed may be different, management may be different, the genetic base of the population may be different. So sometimes we select an animal based on a PTA in a different evaluation, we think it's very high. And then when we think about our specific region, the base of the population is higher, so that animal is actually not going to improve. So we got to be extremely careful when you look at the breeding values from different countries. Weather is also a big thing, so animals may be dealing differently with different climates. So all of that may influence how PTAs are calculated, and then bringing semen from another country without proper corrections may be problematic. Additionally, there are some traits that are measured differently across countries, so that will also differ. In that example here, we are seeing that if we select for stature, which is a trait that's not supposed to vary that much, right? Across Denmark, US, and Canada, across the top 100 sires, we had about 15% of the sires not being the best. So that may lead to problems into our evaluation. Next slide, please. Another problem of using different herd books is that PTAs will likely vary. One because of the environment, as we said, and the other one is because of the different genetic base. In either case, we may select the wrong bull. Sometimes we will have different daughter records measured in different countries. but that still lead to different PTAs. So if you look at those PTAs here for milk, protein, and fat, the animal in the right looks much better than the animal in the left, right? So in the left, we have the values are not that different, but in the left, we have the values in pounds. In the right, we have the values in kilograms. So the animal in the right is basically twice higher in PTAs than the animal in the left. Can we just go through the animation in the slide? I think if we just pass for the next slide, it's gonna show. So when you look at the pedigree, that's actually the same animal. So the evaluation in the left is in the US. Well, you can tell because it's in pounds. The animal in the right is in Canada, but that's the very same bull. Well, it could be that that bull performs better in Canada, or it can just mean that the genetic base is lower in Canada and higher in the US. It doesn't really matter. Comparing those two breeding values, those two PTAs, does not make a lot of sense. That bull has no daughters, so very, very likely that's just because of the genetic basis of the two countries being different. So the same bull can have very different PTAs depending on the country. Next slide, please. So how we can calculate breeding values across multiple countries? Well, one way is to use MACE. So MACE relies on what we call the deregressed proofs from PTAs, which are just a little bit of math to remove some of the pedigree information from the PTA. Bulls with more data, more daughter records are going to have a higher weight into that. We put it together, those deregressed proofs, which are basically fancy PTAs. We put it together, we weight all of those bulls, their accuracy into that machine for all the countries, for all the traits we use, and the result is going to be one breeding value for each bull in each country, for each trait. They also do MACE for many breeds. It's a great tool, but as I said, there are some limitations. For example, not all traits are going to be measured in every country. Not all traits are going to be interesting for every country. So Alina mentioned, for example, methane emissions. Not every country will have methane emission evaluation. Just a few of them will have. So I'm not sure right now, but as far as I know, it's not including MACE traits like that because we just don't have enough evaluations to put that. So traits that are probably a focus in some regions are not going to be a focus in a different one. So it doesn't make sense to include them into international evaluations. In the USA, and again, that's not per se an international evaluation. However, it is a large country with many environments. I like to study how animals' genetics vary across the country. What we do right now, we fit the whole data in the whole country, calculate a single PTA for every bull through the whole country. But what it could do, we could split records into regions or into states, and then calculate one PTA for each state in each region. That would be the ideal scenario for an international evaluation in which you have access to all data, all phenotypes, and all pedigree, and we fit each region as a different trait. And then that will result in a PTA for each animal in each state or region with no loss of information. Because when you do the deregressed proofs from the PTAs, we may lose a little bit of information, which accumulates over time. Next slide. So using external evaluation can be done mostly in two different ways, especially when you talk about genomics. Sretanandanov in 2017 developed this study in which he called them small or large countries, but that was based on the amount of animals in their genomic evaluation. Large countries, they do not need to improve their genomic evaluations that much by adding data. So he focused on improving the evaluation in smaller countries, and he tried in two different ways. One is a method similar to MACE, so he used external information from the large countries to improve data from the smaller country. He also tried to incorporate all data as we do here in the US. He considered both countries as different traits, but he brought data from all from both regions, and that yielded the best results. But that's unlikely to happen. We're going to talk about that in the next slide. The best way, from what he did, he calculated SNP effects from large countries, and the results were good. In 2019, I continued Saratan's research on trying to advance that, trying to use the SNP effects from different countries. However, we know that people are not going to share a lot of data. So what we did, we created a simulated population. So a brand new population that doesn't exist, and use that population to calculate fake phenotypes, reconstructed phenotypes, and that would allow us to run an evaluation with that reconstructed population without the need of sharing data. Next slide, please. So as we can see here on the last column, the right-hand side, that's the multi-trait reconstructed population. That yield results that are slightly lower than the multi-trait GBLUP, which is the fourth column, but there is a genetic gain. Ideally, the multi-trait GBLUP was going to happen. So every country is going to share all their phenotypes, their genotypes, their pedigree. We're going to put everything together. We're going to evaluate everything together. That's always going to yield the highest accuracy. Especially, as you can see, country number 4 in that table, that's the smaller country, had only 1,000 genotyped animals. That country had the best benefits. Now, what are the problems? Well, we know that the multi-trait evaluation across countries is very unlikely to happen because data copyrights are very problematic, and competition across countries limits how people share data. In addition to that, when I presented that study to some stakeholders, some folks from the larger country said, well, if my country is not going to benefit from that, why should we share our data? And I didn't have an answer for that. The only thing is that, well, you're going to help your competition. So that becomes very problematic, and that's why we need to develop such tools. Next slide, please. So genotype costs are decreasing, and whole genome sequencing is becoming cheaper even faster. Trends are that the whole genome sequencing for lower density is going to be cheaper than SNP genotypes in some cases. We know that people are not going to share phenotypes. MACE is still one of the best tools we have. Methods for external data are improving. However, not every country is going to be a member of Interpol. What's going to happen is that as we increase the precision of agriculture, difference between genetics, ideal genetics for each country is also expected to increase. So relying on evaluations from different countries will become less and less and less recommended. There is still research being developed in that without the need of sharing data. So that will be a little bit more similar from what I proposed in my study from 2019. The group from, from Iowa State University, led by Dr. Juan Pedro Steibel and his study Blessing, they are implementing a new technology that is comparable to what I proposed, but it is a huge advance from what I proposed in 2019. So they didn't publish anything about that yet. I looked until yesterday, but soon something is going to come. So pay attention to those names. They may have some very exciting news pretty soon. And that's expected to bridge those gaps, and that's going to benefit especially countries that are still small in number of genotyped animals, a number of records, and so forth. Next slide, please. So in conclusion, using evaluations from different countries is not recommended just by using raw evaluations for different countries because of genotype by environmental interactions and different genetic bases. And comparing animals from different evaluations is incorrect, and it may result in the wrong bull selection. That includes comparing animals from the same country, from the same program, but in different years. So every time we're comparing animals, we should only compare animals in the same bull evaluation. Accurate multi-country evaluations depend on data sharing. And small countries, and I'm saying here small again, based on number of genotyped animals, they benefit much more than large countries. Unfortunately, sharing data is very unlikely because of data copyrights. Nobody knows who actually owns that data. It could be the farmer, could be breed associations, it could be whoever runs the evaluation. In some countries, the government owns the data. Some countries, the genotyping companies own the data. Sometimes nobody even know who owns the data, and that is problematic when we want to access and share and work with that. So we need novel technologies. Luckily, those new methods are arriving, and the key for improving those international evaluations and benefiting from data from different countries is advanced in statistical methods. With that, thank you for your attention. I am happy to take any questions.
Thank you, Breno, for your interesting presentation. Do we have some questions from the offline audience? Seems like no. Then I can ask you the thing from the translation. What exactly should we be careful of when we use international PTA for our internal purposes? And how we should manage the risks?
So the main problem is, so some traits are going to vary less than others. But for example, as I show in that example, the same bull will have very different PTAs. So if I see a value, let's say, of 1,000 for milk, that may be a different thing, because it just means that daughters of that bull are going to be 1,000 whatever units, pounds or kilograms higher than the base of that population. Now, if the population of the country that you're comparing to is lower than ours, that means that, for example, we are just bringing an animal that's actually going to decrease our performance because that animal is better than the animals in that country, not necessarily in our country. So that's one thing that we got to be extremely careful, is the base of that population. The other thing will be, and for milk, not so much, but for traits like reproduction, disease, that those traits are extremely specific sometimes on how they're measured and to the environment that the trait was measured. Therefore, it could be problematic that we'll be selecting an animal that does really, really well in different countries, but not so much in ours. For example, back in Brazil, we used to buy a lot of US Holsteins because they have higher milk production than our Holsteins. What happens is that Brazil has high heat and high humidity, and even though those animals were cooled, they were not suffering that much with heat stress. They were developing hoof diseases because of the high humidity, which they usually do not experience here. So importing animals from the US, from Brazil, may be problematic because part of that adaptation is not something that people in the US care so much about. So they do not breed for that. So, but yeah, the case of the PTA, it may just mean that those PTAs are specific to a base of a population. So we may have a very high PTA, but it doesn't mean necessarily that that PTA is going to be good for our population base. Does that make sense?
Yeah, I think so.
So one thing that can be done, one thing that can be done, if you have a bull evaluated in your country, you can compare that bull to the same bull that you're testing in the other herd book. So you need something to compare with that animal in that international evaluation. So I have, I don't know, bull A in my country. I know that bull does well in my country. If bull B in that different country does better than bull A, I could expect that bull B will be better than bull A in my country too. Of course, if I ignore the difference in environment. But I need something to compare otherwise I may be selecting an animal that's actually going to decrease my performance.
Yeah, sure. Your point is quite clear that all the PTAs should be comparable to each other in order to select the right animal. Either it is a bull or a cow. Okay. Thank you, Breno. It was very interesting.